Yes, so welcome student, and we are going to start the modern algebra, also known as the abstract algebra, which is a branch of mathematics in which we will study the structure of the sets. So people can ask why the name is this abstract algebra, right? Why is it the term, the name, the abstract is related to something as a literally algebra? We know that the structure of the sets, right? So to start the modern algebra or abstract algebra, we need so many sets. Like for example, we know the real number, complex number, rational number, natural, integers and many more. So these are the example of the set. We will learn some other example of the sets, and we know very well how the real numbers look like, what are the structure of the real number and the complex number, and then we will employ the structure of real and complex, the property, whatever we are going to see, we will extend this notion to the arbitrary sets also. So in this lecture we are going to start so in order to start the abstract algebra, the first question is why this abstract stand for. So my answer is, you have to, this is the homework for you. My answer is yes. The abstract extend literal meaning also. Okay. So and this course is designed for BSc, MSc and also for IIT JAM, CSIR and all competitive exam include the GRE, NBHM as well ISI, TIFR. And all the exams we will cover all the questions also. So this is the first lecture of the MathShrine. So if you remember, this is the homework I am giving you, but some more help I can give you. If you can see the tree, if you see the structures of the one leaves, you can extend this notion of this structure to the another leaf of the same tree. In the mathematics, in the same way, we are going to retrieve some information, or you can say some hidden information from the sets to the, as we know, right, very well. So with the help of this mathematics, this abstract algebra, we are going to retrieve the information, or in other words, we are going to learn the structural or structure property of the sets. Sets may be like, by definition, I assume that you already know what are the sets. Of course, we will learn some new sets example, and you can also ask, or you can also write some example of the sets. Then we will discuss the same the structure of the sets with the help of its elements, how the structure look like. So this we believe that if you also can give me some example of the sets, it doesn't matter if it exists or not, whatever if you tell me, then we will think together on it. Okay. So definitely it extend literal meaning also. For example, I had said, if you see the leaf, there is also abstract algebra. If you collect all the leaf of a tree, definitely there is a group theory, there is a ring theory also there. So what are the properties are there? Everything not in your course, but of course some of the concept are here. The first one, if you remember, the groups, right? Like I say, take the collection of all the leaves of a tree. They will form groups or not? This is the homework. And once they form the group, then we can calculate the more properties with the help of this abstract I mean in this course or in this subject. Another one, the rings also. So the people can ask, if we have already done, the group is itself a with the help of group we can retrieve the information or some hidden information. Or suppose if I have a group, for example take the real number, complex number, then why do I need to go one more step, say the rings? Of course with the help of group definitely we will be able to retrieve the information, but if we have a ring we can retrieve the more information. So this will be the next step, right? For example, like I have a phone, right, normal phone. If I can buy some better phone, that will include our calling, internet and so many more, right? So if you see, this is the webcam, that's which we are taking out the classes. You can ask, this normal phone also can be useful. Of course a normal phone will be the useful, but there is a problem that the normal phone cannot capture the good videos here. So that's why we are using this. So if we need, the more we will use the rings, fields also there, modules also there. This is not in your course, but for a student who is in BTech preparing for GATE exam, so it will be useful for them. So we will discuss in the separate lectures. I will mention as a modules. Vector space, of course we have already done in the linear algebra, lattices, right? So lattices and the modules, these topics will be applicable, will be important for who doing the PhD in the algebra. So these two concepts will be useful there. It is not in your course, but anyway at the end we will discuss that in the details also. Okay, so let us start. That's another definition is already written. Abstract algebra is a study of algebraic structures. Okay, so let's go to it. So yeah, any doubt? Any student have any doubt? There are so many definitions are available. You can Google and get so many definitions, right? But what stands for us for the MathShrine, through the abstract algebra, we are not able to retrieve the information of some sets, not every set. Of course, if I can give you natural number, I can ask you 1 plus 1 will be 2. And then again add the 1, you will get 3 and so on. So what we want, that we want to retrieve the more information from the sets, not from the normal set only. We are interested to retrieve the structural property of some complicated set. Then if we are able to retrieve the information from the normal set like discrete set like integers and some this kind of the set, then definitely the same definition and terminology we will employ for higher. Okay, so let us see some observation, right? So the first observation is, I have written one set phi. This is a set known as null set. Another set I am writing 1, right? Another is 0. All right. One more 0 1, and another set is 0 1 2 and so on n. This is a set with n element, right? That means the cardinality. Okay, so also we can write the set of natural number. This is known as 1 2 3 and so on. Integers 0 1 2 3 minus 1 minus 2 and so on. This is our set of integers. We can write some more example. The another one, set of rational number. all p by q such that p and q belong to integers and q should not be the 0. Alright. So if q is non-zero, then this will look like, can you tell me, 0, 1 by 2 and so on, minus half, whatever of this you can write all the possibilities. Similarly, we already know what is the real number. So real number look like something like this. So this is it's called something interval. The open interval, that the end point not included, but between the end point all the numbers are included. Another, the complex number. What is the complex number? This is the collection of a plus b iota such that a comma b belong to R. Alright? Okay. So another q root 2 collection of a plus b root 2 such that a comma b belong to the real number. Alright? Any doubts? If any student have any doubt, please ask. So these are the set I have written, and I can ask some question, or naturally some question will be arises. If we remember the phi, alright? Okay, let's take the first. So there are many more examples. Definitely we will write one by one. If you see the phi set, the first set is phi, have no element at all. That's what we say this is the null set, empty set, whatever the people used to say. That another name is empty set, right? Or the null set. So you tell me, if I have a phi, then you tell me if I take any two element of the set and if I add the element, will it be again in phi? So answer is no, because the phi have no element. But other way around, let us rewrite it in other way, like can we get some element from phi if we add them or multiply them, or if we apply any operation, then will it be again the member of phi? The answer is yes. See this set, I say this is the A. If you remember, A is equal to 1. So for every A comma B belong to A implies that A into B again belong to A. So I have an element 1. If I multiply, take A is equal to 1, take B is equal to 1. If you multiply 1 into 1, again it will be the member of A. Right? So it meaning that if we multiply the elements of A, it will not go the outside of the A. So if this is the set A, 1 is here. If you keep on multiplying of its elements, it will be again inside A. The element will not go the outside with respect to the multiplication. Right? So in these cases, we say the A is equal to 1. So A with the multiplication is closed with respect to multiplication. We don't need to write because operation I have written. So what do you mean by the close? So another definition is binary operation. Hold. So A is equal to 1, the binary operation on A is multiplication. Right? If we multiply, it will be again. But if I ask you something, so See, if I say A equal to 1 with operation addition, see, this is the A, this is the 1. If I ask that can we add, here I am asking the A is closed with respect to addition or not. The meaning or the addition is a binary operation on the set A. Tell? Yeah, right. So this cannot be the binary operation because here the multiplication is a binary operation on this set, because if we multiply the elements are not going out. But here if you see the addition, if we keep on adding element, like I have 1, okay, so what is the meaning? It is means for each A comma B belongs to A, then A plus B also belongs to A. Is it true? Tell my friend. The answer is no. Take 1, A is equal to 1, B is equal to 1, what you will get? 2 not belong to A. This implies that this set with single element 1, addition is not a binary operation on the set A, because the A have element 1. If we are adding 1 plus 1, we are going outside of the set. Therefore, A is equal to this set with operation addition is not a binary operation. Under what condition it will be binary operation? If we add the elements, it should not go the outside. So this is not a binary operation. So this is not closed. Okay, this is not closed. बोलिए जी कोई और? So now you have to check, this is the homework, that the set 1, this is closed or not. Meaning now you take the subtraction. The way we had seen for multiplication, the answer is positive. For addition, answer is negative. You have to try, the answer will be, I hope it should be again negative. Why? If I take A is equal to 1 and B is equal to 1, then 1 minus 1 will be 0, and this set have only one element, 0 is not there, so this is again not a binary operation, or this is not a closed. Then similarly you have to try 1. Replace the subtraction, apply the division. Okay, you try this also. So आप लोग ट्राई करें जी. Yes, I think you guys can try, right? So let us see another example. Okay, so modern algebra. So yes, give me 1 second, guys. One second. So there is a clarity issue. 1 second. Anyway, fine. That can be manageable. Yeah. So take another example. 0. The set A is equal to 0. So the first one, if you see 0, take addition. This is also closed. Again, take 0, then take subtraction, again closed. Again 0, take multiplication, this is closed. Again take division, homework for you. Okay, what is this meaning? See the set with single element, one element, addition. Now we have one element, 0 plus 0, again 0. So this is closed. Again subtraction. Now 0 minus 0, again 0. So this is closed with respect to subtraction also. Third one, 0 into multiplication. This is closed. 0 into 0, again. This is you have to try. Okay. Another example, 0, 1. Okay. So the 0, 1 is here, and yes. So let us check first addition. So this is not closed. Why? See, this is the set. 0 plus 0 is equal to 0, alright. 0 plus 1 is equal to 1, alright. Now you change it, so take the 1. 1 plus 1 is equal to 2, right? This not belong to this set. We got some element 1 plus 1 not belong to this set. This implies that this is not closed with respect to addition, right? So this is not closed. Now let us change this. 0, 1, take multiplication. Now check. So this is closed or not? Tell. Okay. 0 into 0, 0. 0 into 1, 0. 1 into 1, again 1. Whatever element we are choosing here, A and B, if we are multiplying each other, we are inside the set, we are not going outside. So this is the closed with respect to multiplication. Right? Now check again. Remove this addition. So keep it here, subtraction. Okay. So tell me, in the subtraction 0, 1 not closed. So check 0 minus 0, again 0. 0 minus 1, minus 1, minus 1 not there. So this is again not closed, right? Alright? Okay. So let us write natural number, and then integers, and then rational number, then real number, and then complex number, and then irrational number, and then we can write positive real number, negative real number. And also one can think positive rational number. All right. So here all right. Here write addition, then multiplication, and then subtraction, and then division. The homework for you have to write some more operation the way I had written here. Addition, subtraction, and you have to tell me or write. I had written 4 operations, 1, 2, 3, 4. You have to write. You have to write. UHW, UHW, UHW. You have to write some operation. Okay? All right. So, yes. So, we are testing the binary operation. Or this is closed or not with respect to the operation. Take the natural number. So, you tell me, if I add two natural number, 1 plus 1 again 2, 2 plus 1 again 3, again the natural number, right? The meaning, the addition of any two natural number is again a natural number. This implies that the set of natural number is closed with respect to the addition, so the answer is okay. Similarly, the multiplication of any two natural number is again a natural number. So this is also correct. Alright? Similarly, you tell me about the subtraction. So this is not. Why? See, 1 belongs to the natural number, 1 minus 1 is equal to 0, 0 not belongs to the natural number. 1 belongs to the natural number, 2 belongs to the natural number, 1 minus 2 minus 1. Minus 1 again not belongs to the natural number. So, subtraction is not a binary operation on the natural number. Meaning, if we apply the subtraction on the natural number, the elements of natural number will go outside of the set. So, the set of natural number is will not hold a binary operation with respect to the operation subtraction. Similarly, division also, 1 is natural number, 2 is natural number, 1 by 2 not natural number. So this is also not. This operation you have to try. This operation you have to think. You have to think. You have to think. Now come on the next set of integers. So this lecture we usually starting from 0, but believe me, we will reach, and we are starting from 0, we will reach to the infinity. Okay. So we are familiarizing of the some sets because some BSc students do not know. So this is for the integrated students mainly from beginning, but after 4 or 5 lectures it will be I miss some heights. So then let's see set of integers with respect to addition. Tell me, correct? Right? So addition of any two integer, again integer. Multiplication of any two integer, yes integer. Subtraction, again integer. Division, no. Using same argument, here we can conclude one more thing. The rational number with respect to addition, yes. This you have to think and tell me. This is the homework. Division, no. Divide the 0. Real number, yes. Right? Or you can think. This is the homework. Okay? No. Yes. No. Integer plus, no. Yes. No. Yes. Yes. No. Yes. No. Right? I am giving you the 5 minutes. Please look it carefully. If not, then I will look it again. And if any doubt, please tell. Okay. Any student have any doubt? No. Shall I erase? And please write all remaining these 4. Okay. So this is the gun. So let us some example. You have to think on it. Set of leaves of a mango tree. Similarly, of a coconut tree. Okay. The answer is this will form a binary operation with respect to operation. आपको बताना है. This is the homework. tell me the operation, what kind of operation is there that the set of leaves of a mango tree forms the group. Oh, I'm sorry, forms the binary operation. Meaning, if I take any two element and if we apply with respect to that operation, it should be again some another tree of the leaves. Alright, similarly for the coconuts also. And another set of students of MathShrine. Same you have to tell. Okay. 3 I have given you and you have to write 4 example at least. Okay, like set of your family members. Your family member. Okay. So question is, your family members are close with respect to the what operation? What kind of operation is there that your family member will be close? So you can try, and then okay. So some students have to go. So yeah, but we still I couldn't start the chapter. We are moving here between the basics, but make sure tomorrow onward you should not have any plan, because I cannot skip the class or stop in between. Okay. So today actually this is the first day, so now it's fine, but careful. Okay. So the next lecture we will start the topics, the groups. We will write the definition. We will write 3 definition of the group. What is our lecture 2 program? Lecture 2. We will write the group definition. 3 definition. One is bookish definition. Whatever it is books that you have to write. Another one geometrical definition, and one will be our own. So we are going, or our own means this is the real life example. Real life definition. Okay, so in the next chapter, what we are going to do, we are going to write a group definition. What is the group? The 3 definition. One definition will be from the books, that whatever we know. Another will be geometric approach definition, and the third will be our real life example definition, how these group theories are working. Okay, so see you in the next class. I will be glad if you can tell me these 3 definitions by your own in the next class, or you can write it and send it to me at the MathShrine@gmail.com or my number 9013. These are, you can ask your queries here. So this is the number 13488-680, or you can visit www.mathshrine.in. Okay. You can join also the Facebook page MathShrine MS, and definitely some teams are there, some many members are there, I think 5 or 6. They will answer you within 3 or 4 hours. Okay, so see you student in the next class. Thank you. Okay, you can write it and then I should start. Okay, so shall we stop here? You have written?